Hi everyone, today's lesson is rotation. Our objective for today is to graph rotations and identify rotational symmetry. Now open your book, page 265. We'll start with check skills you need. Number 1, when a figure has a fractional symmetry, one half space the other half exactly. Yes, of course it should match the other half exactly. In these questions 2 to 7, from question 2 to question 7, classify each angle as acute, right, obtuse, or straight. 180 degrees, this is straight angle. 150 degrees, yes, it's obtuse angle. 95 degrees is obtuse angle, and 20 degrees is acute angle. 35 degrees is, yes, acute. And of course 90 degrees is right angle. Okay, now back to the lesson. Let's start with the meaning of rotation. A rotation is a transformation that turns a figure about a fixed point. This fixed point is called center of rotation. A figure has rotational symmetry if it can be rotated 180 degrees or less and exactly matches its original figure. When you rotate a figure about a point, the image is congruent to the original figure. A rotation changes only the position of a figure. The angle of rotation is the number of degrees the figure rotates. A complete rotation is 360 degrees. As you can see in this figure, this is the center of rotation, and here the rotation is 90 degrees, 180, and 270 degrees, 360 degrees. Okay. In the first example, we have here this shape, this figure, and we need to find the angle of rotation of the figure. Okay, look at the figure. We can see here, yes, it's divided into 5. Yes, we can divide it like this. So each one of these, when it rotates, it can rotate, yes, with this angle. What's the measure of this angle? This angle is, yes, fifth turn. So fifth a turn, and a complete turn is 360 degrees. So it's fifth multiplied by 360 degrees, which is 72 degrees. This is the angle of rotation. Okay. Now to the workbook. Page 78. A rotation is, yes, a transformation that turns a figure about a fixed point. And the center of rotation is the fixed point about which a figure is rotated. The angle of rotation is the number of degrees a figure rotates. A figure has what if it can be rotated 180 degrees or less and exactly match its original figure? Yes, it has rotational symmetry. Excellent. Now in this figure we want to find the angle of rotation. Let's do the same as the previous example. Yes, do that. And now, how many parts can we divide the whole turn into? Yes, count them. 1, 2, 3, 4, 5, 6, 7, 8. So the image matches the original figure after what part of a complete rotation? Yes, after 1/8 of a complete rotation. So we multiply 1/8 by the measure of a complete rotation, which is 360 degrees, and we get 45 degrees. So the angle of rotation should be 45 degrees. Now it's your turn to solve this question. Okay, try by yourself and come back. Welcome back. Here we can divide it also like this. Yes, it will be divided into 5 parts. Divide the complete rotation into 5 parts. So it should be 5th multiplied 360, which is 72. Now guys, we have this figure. This is a clock, okay, and it's here in the positive direction of x. As you can see, yes, in this direction. No, this is not the direction of a clock to move. Yes, this direction is called anti-clockwise or counterclockwise direction. So this direction is, yes, is called anti-clockwise, and this direction is the positive direction. Okay, here we have 0 degree with positive x-axis, and yes, here 90 degrees, here 180, and back here, yes, it's 360. So a complete turn is 360 degrees. Okay, now with the opposite direction, it's called clockwise. This is the negative direction. Okay, so this clock moves in the negative direction. Okay, yes, and we can do the same. This is 0 degree, so when we come here, it will be negative 90 degrees, negative 270 degrees, and of course negative 360 degrees. Now you know that 0 degree, 360 degree, negative 360 degrees are all the same. And also 90 and negative 270 are equivalent. 180 and negative 180 also are equivalent. 270 degrees and negative 90 degrees are also equivalent. Okay? Now, summarize this again. This is, yes, the positive direction, which is anti-clockwise or counterclockwise. This is the positive direction, and the other direction is the clockwise, which is negative direction. Yes, consider that we have positive direction of x. Yes, we have here, this is 0, 360 or negative 360. And this one, yes, it's 90 degrees with the positive direction of x, the red line. The positive direction of x. And, yes, here is 180 and negative 180. And, yes, 270 and negative 90. Okay. Now, let's start with the coordinates. Quarter a turn, that's 90 degrees or negative 270 degrees. Okay, what a quarter of a turn makes to a point x and y? Yes, let's see. It will, yes, change the position of each of them, change x with y, like this, and yes, opposite of the first coordinate in the image. Okay, so if we have a point like this one, A, 2, and 3, just change the position and yes, opposite the first in the image. Let's see the figure. We have here the point A, it's 2 and 3. And this is A prime, which is, yes, its image by rotation 90 degrees or negative 270 degrees. And prime is negative 3 and 2. Excellent. So this is 90 degrees or 270 degrees, negative 270 degrees in the other direction. So this should be negative 3 and 2. Again, change the place, and after that, opposite the first in the image. This is the image, opposite the sign of the first in the image. Okay? Now, with 3/4 of a rotation. 3/4 of rotation, yes, that's 270, or as a negative, negative 90. And what it does, the opposite, yes, it does do exactly the opposite of the previous one. At first, change places, and after that, change opposite the sign of the second in the image. Focus with me, in the image. The second in the image, not the original. Change the second in the image. Okay? Okay, let's see our example here, 2 and 3. Also, we are going to, yes, change places, and after that, opposite the second. Let's see the image. Yes, we have here A, and here A prime. A is 2 and 3, and A prime should be, yes, after rotation to 170 in the positive direction, or negative 90 in the negative direction. Okay? Yes, now it's A prime, which is 3 and negative 2. And with rotation half of a turn, yes, that's 180 degrees or negative 180 degrees. And when we have a point X and Y, we are only going to opposite the two signs of the two coordinates. So it should be negative X and negative Y. For example, if we have A, 2 and 3, look with me here, that's the point A, 2 and 3, with rotation in the positive direction 180 degrees, or in the negative direction 180 also, so it's negative 180. Yes, the image A prime is negative 2 and negative 3, just opposite the two signs of the coordinates. What about a complete rotation, a complete turn? Yes, that's 360 degrees or negative 360 degrees. And in this case, any point X and Y, yes, nothing will change. It will remain as it is, X and Y. So, for our example 2 and 3, let's see. This is the point A, and where it, yes, it will turn 360 degrees in the positive direction or in the negative direction. Yes, negative 360 degrees, they are the same. It will come back to the original place again. So A prime should be the same place as A, the same coordinates, 2 and 3. Thank you guys for listening. That's all for today. Goodbye.